So I have way too much. Thank you for the kind introduction. And I have way too much to tell you, even though I've cut out lots of slides. So all creatures must move and act in space to survive. We spend our lives living and acting in space. Even plants need to move toward the sun and away from the wind. Bacteria need to move to where they can infect. When motion ceases, life ends. The elemental action in space is to approach the nutritious, avoid the noxious, and that elementary act that one-celled creatures and even viruses that aren't quite one-celled take is replete with emotion. So all thought begins as spatial thought. And by spatial thought, I mean acting in space with the things in it. It's not the entire edifice, but the foundation. And again, look at the words. So space is special, it's supramodal. We know about space from all of our senses. Blind people can often navigate better than I can. So it's supramodal. It takes up about half the cortex. It evolved way before language. It's essential for survival. If we didn't know how to get home or how to get food in our mouths, we'd be in trouble. It's the basis for other knowledge. I'll talk about that. It's not like geometry or physical measurement. We don't have those devices in our head. We learn about space from our perception and interactions, and they bias the way our representations of space. So and again, that's another talk. So I hate to say first, because it's happening all the time, we put the world in our minds, and I've distinguished, and other people have too, 3 spaces of action: the movements of the body per se, so dancers, or anytime you're doing something around. So the space around the body in reach of hand or eye, and the space of exploration that you need to piece together from different experiences, some of them actual and some of them virtual, some of them through language. So in each of those is constructed mentally in different ways. We also put our mind in the world. These are the spaces we create, and a few examples. I'll talk about some: maps, sketches, urban spaces, social spaces. So these are designed for various reasons. So we use space and the things in it to think, communicate, and create. The evidence for this comes from brain, from language, from gesture, from graphics. And I'll have time to go through just a bit of that. First, brain, and this is remarkable work done by John O'Keefe and many others in his lab, including the Mosers, and they won a Nobel Prize for the work I'm about to tell you about. O'Keefe had long found, by putting single neurons in hippocampus of rats as they were moving around an open field, that there were single neurons that fired when a rat was in a particular point in the cage or in the area it was exploring. And those same neurons fired every time the rat went there. So they were called place cells. But those place cells in hippocampus weren't arrayed spatially. Although he called it a cognitive map, they weren't arrayed spatially. And the Mosers, working in his lab, found grid cells 1 synapse away in entorhinal cortex, where there are spatial arrays. And it was quite remarkable. There, the place cells are related spatially. Subsequent work, much of it out of UCL, also looked at humans. And you can look at humans when they're about to undergo surgery for epilepsy, and some of them will volunteer to have electrodes put in their hippocampus. They have electrodes anyway so that the surgery doesn't hit critical areas. And in people, those single cells that respond to places in rodents, in people, they respond to events in time, people in social networks, and ideas in conceptual networks. And the relations among them, among the temporal events, the social relations, and the conceptual ones are mapped in grid cells. So this is very basic evidence that the same brain structures that represent space and things in space and spatial relations represent abstract ideas and the conceptual relations among them. So the brain work is quite impressive, and I got very excited when I read about it. So this is just summarizing it. So the mind is too small. When thought overwhelms the mind puts thought in the world. So imagine doing your taxes without pencil and paper. We need that support, or without your calculator. We need that support. So putting thought in the world is primary ways we put thought in the world are through words, gestures, including actions of the body, facial expressions, and graphics. And I'm going to talk about first a bit about language, not enough. So again, arguing that thought comes from actions in space, we talk about our minds going from thought to thought along relations, just as our feet go from place to place along paths. So there are paths of thought. And our hands act on ideas just as our hands act on things. So we talk about raising ideas, throwing them out, arranging them, and they're all the words we use for acting on objects, but here the objects are ideas, and they're often accompanied by the gestures, right? Raise, throw out, rearrange. So our feet, one thought leads to another. We can follow a straight path. We can go in circles, zigzag, wander. We can go up. We can kick around. So we do some action on ideas even with our feet. Hands, again, raise ideas, toss them out, tear them apart, pull them together, arrange them. So thinking is a path, and ideas are objects. And I know Lakoff came up with many of these ideas, but I don't think he integrated it into hands and feet in the way that I am trying to do now. So we also have figurative spaces. We can be out of depth, think out of the box. We can be at the top of the class, again with gestures. We can be feeling up. We can be down in the dumps, into a depression. We can get closer, get apart. We can open a field. When you start hearing these spatial expressions, they're all over the place. And again, accompanied by gestures, getting feedback. So gestures and graphics are a direct form of expressing meaning. If I say we've grown apart, you can get that gesture no matter what language I'm speaking or you're speaking, even if you don't understand my words. So words are indirect and for the most part purely symbolic. So now, now I'm going to talk about an elementary semantics of gestures and graphics. So things, dots, lines, arrows, and boxes. These are all abstractions from the world and from our actions. So lines in the world, they're there. The horizontal is very apparent. Then there are the lines we make in the world, the paths that we make with our feet, and other people follow them, and they turn into whole networks. Clay famously said, "A line is a dot that went for a walk." So we get networks in real space. They get quite complicated in art. These get represented in graphics. Maps are one of the oldest things that we find on stones and caves all over the world. This is from a valley in Italy. I don't know exactly where it is. They're 3,000 years old, and they look like modern maps. They give you the road structure and the buildings. So it's mixing perspectives, which isn't a problem. They're useful. So networks, paths form networks. Here the streets get straightened. We turn them into diagrams. This is the famous London Underground, which rectifies everything is parallel, perpendicular, and the distances aren't represented well and the angles aren't quite right, but it's useful. I once used it for distance. I don't recommend it. But I got there. So lines have many meanings. This is Steinberg, and you can see the line is the Grand Canal. It's the street looked at from above. It's the Nile. It's the top of an aqueduct, the top of the table. It keeps changing meanings, this Steinberg. So we use that idea of networks to represent many different kinds of networks. So these are networks of neurons, and they are networks. Family trees are networks. They're rooted with, these are social networks. Our participants drew. You're at the center. So centrality is another spatial concept we widely use. This is the tree of knowledge, porphyry, that came from Aristotle. Here's a kind of a verbal representation of it, but those trees appear throughout history representing different kinds of things, but originally to represent knowledge. Phylogenetic trees, transportation trees, computer networks, semantic networks. This is the history of Cubism and abstract art. It was developed at the Museum of Modern Art, and it's quite famous. Jokes, this is Steinberg again. We have a network of decision-making, not yet, but now, never. And art, this is a Mark Lombardi, an artist. These were filled a wall, and they're beautiful, and they're connecting social, political, economic, and people study them as when they're on the wall. So networks of paths and places are created by actions of feet. And in fact, those representations in place cells and grid cells come from the pattern of little feet from the rodent's feet. It's their movements that create them. They get abstracted to lines and dots and into maps, and they're used to represent networks of neurons and ideas. So we have dots for places and ideas, lines for connecting or relations among them, and we're going to get more. Our hands point, and points are directed virtual lines. I'm pointing at that pillar there, and you can follow my point. It's indicating that I'm looking there, and you can, it's a line between me and that pillar. And this is this is a universal gesture made by babies. Even blind babies point. And blind people gesture even though they haven't seen gestures. So these are, again, elements, a directed line. So again, gestures and graphics have direct meanings, marks or actions in place and relations in place, and they create abstractions and also models. I'll give you more examples. We can think of a minimal diagram, a bit like a proposition, but without the truth value. It is 2 points and a line linking them might be, and you can use this to create multiple diagrams. Okay, more on the spatial semantics. So place in space is meaningful. Proximity we talked about. We talked about centrality, direction in space. Up is good, more. powerful, desirable, because you have to go against gravity. And that's the major organizing force in the world we live in. The horizontal is neutral, but reading and writing order affect how we think about time or goodness or more or powerful. The horizontal matters, but it's cultural. It seems to come from reading and writing. And we've done work on that. And there's a huge literature now on direction in space as influenced by reading and writing order. And then we have marks or actions in space. Just to illustrate more on up is good, this is an evolutionary tree, and man is always at the top, and it's always man. And we looked at a number of diagrams of that type, and up is always good. Family trees go backwards. I mean, they start with, George Washington or whoever, whatever king is in your family. And that's again because that person, again, usually a man, is the progenitor, the archetype, the proto-language. Linguistic trees go that way. Okay, so we have place, direction in space, now marks, and here we have dots, lines, arrows, boxes, blobs, and icons. And their geometric action and gestalt properties suggest context-dependent meanings. They're abstractions, so you need context to interpret them. They can be iconic. I'm not using it in a Persian sense. It's a very casual use, meaning some depiction that people can recognize. I'm sure Nelson Goodman would not like that, but all of you can tell that's a chair, right? And there are metaphoric ones like scales of justice, schematic ones like little dots, symbolic ones like justice. And again, we have the meaningful abstract forms, points, lines, arrows, containers, and boxes. And those containers get used in other kinds of graphics like bar graphs and tables. So we've done research on several of these semantics. So it's a kind of empirical semantics. With Jeff Zaks, we looked at how people describe relations either in a bar graph or a line graph. We also gave them relations and asked them to produce a graph. So it had to go both ways. And bars contain, so they separate. They say there are a bunch of A's and a bunch of B's, and they're separate. And people would give discrete descriptions to those. But lines connect, so they suggest a relationship. They say A and B can be measured on this same value, but they have different values on this relation. So people gave us relationships for bars, discrete comparison for lines, discrete comparisons for bars. And similarly, if we described something as discrete relations, the height of boys and girls, or the height of 5-year-olds and 7-year-olds, people gave us bar graphs. And if we describe something as a relation, as you grow older, you get taller, people gave us names. So it gave us lines. So the bars and lines actually communicate over and above the actual content. We found similar things in sketch maps. People make sketch maps. Their sketch maps are highly schematized. They aren't analog, and you can divide them into elements like lines and kind of parts of circles and meeting points, and go back and forth between the semantics of the sketch maps and the descriptions of them. We looked at arrows in representations of mechanical systems. So we have a car brake, a bicycle pump, and a pulley system. And we gave people one of these, either with an arrow or without an arrow. And without arrows, we get structural descriptions. They tell us where the parts are. related to each other, what's inside, outside, above, below. With arrows, we get functional, behavioral, causal. They say if you push on the lever of the bike pump, it forces air into the tube, and that puts air in your tire. So they're giving causal descriptions just from the arrow. And similarly, if we give them a structural description and ask them to make a diagram, you get a structured diagram, labeled parts. And if you give a functional behavioral description, you get arrows and you don't get labeled parts. I remember when my research assistant found this, or my graduate student, she came running to me and said, here are arrows, there are no arrows. It worked like a charm. Not every experiment does. Okay, so the problem with arrows, I said all of these are abstractions, and arrows have many meanings. I have a colleague who distinguished 107. I think that's too many. And we came up with far fewer. What is it, 7? So they can be asymmetric, symmetric. They can indicate extent if you're a carpenter. They can connect, point, or label. They can indicate temporal sequences, causal sequences. They can indicate movement, both direction and manner. They can indicate change over time, increases, decreases, and forces that are not visible, but you want to show wind, so you show lines or arrows. And so there are many meanings, and many diagrams don't disambiguate. I'll show you some in a minute. So people ask, and I can't really answer it, when did arrows appear? And you don't see them in cave representations or on petroglyphs. You don't see arrows. You do see, if you go to Ephesus, you can find this foot, a whole series of footsteps in the stones leading to the brothel. So those are arrows. The feet, they're directional. They're telling you where to go. The Middle Ages used fingers, pointers in text, and they're arrows. The first arrows in diagrams, now, and these kinds of diagrams didn't really occur until the Renaissance. There's a small arrow here indicating direction of water. There's another one here indicating the direction of water around this island. And those are the early uses of arrows. There, again, aren't too many. World War II, plenty. The arrows indicating the movements of troop, also the width, the size of the troops, and they were color-coded by country. So we have a corpus of all the diagrams in introductory science and engineering textbooks. And here you see arrows used in 3 different ways without disambiguating. I can get it, even though I'm not an expert in this, but the arrow with those red things there, that's DNA, is indicating movement of the DNA into the cell. Foreign DNA is just labeling. Transient opening is labeling. The regrowth of a cell wall is the next step, the process. So it's many different ways, and you gotta understand why science students get confused. So rock cycle, this is nitrogen cycle, and I show it to scientists, they love it. And I say, what does this arrow mean? What does that arrow mean? And they can't tell me. Same with a rock cycle, beautiful. But what do the arrows mean? Another one, this is how to pass a law in Congress. You go in circles. This was a human error. There was a helicopter looking for a car that had committed a robbery and was escaping, and the people on the ground knew where the car was. So they formed an arrow to signal to the helicopter driver where the car, what direction the car was going in. So that's news report. Arrows in art, there are plenty. So I've talked now about neat diagrams like the London tube map And we have lots more examples, some of those science diagrams that are meant to be clear. And we've worked a little bit on criteria for clarity. Can't talk about that. But they're also messy diagrams and messy sketches that help us think. So this is one of Gary's, and messy, ambiguous lines encourage reinterpretation. Those of you who work with data also know that. Your messy data, you can configure it in different ways, and you don't want to overly formalize it because it blocks the thinking. You want to keep it messy. So we studied architects. We had them design a museum and work through their sketches. We thought they could talk about what they were doing when they were doing it. They couldn't. It interfered with the doing. So we showed the videos of their sessions and afterward asked them what they were thinking as they were drawing each line and explaining what they were thinking. And that they could do. And Masaki Suwa, my collaborator, coded every one of them, arduous task. And the artists reported making discoveries in their own sketches. They would sketch for one reason. And so here they're putting the layout of the museum and the roads. And then an experienced architect would look at that and say that the traffic is going to get clogged, or the light is going to fall badly in the winter. But novice architects couldn't make those conceptual leaps. It's like looking at a music score or a chessboard. You have to have the expertise to make the inferences. So the novice architects could see patterns and use them. They could see things that were directly in the sketch and use them. So they made discoveries, the novice architects, but not the conceptual discoveries that the experienced one did. We brought that into the laboratory and looked at it more closely. In any case, the generalizations are that the more experience you have, the more you make discoveries. It becomes a positive cycle. You then re-sketch and more discoveries and re-sketch. And more experience gives you conceptual discoveries. We also found, we asked them, what happens when you get a new idea? And they said they reconfigured the parts. So that ambiguity, like the wife and mother-in-law or the duck rabbit, that ambiguity allows you to reconfigure and find new things. I mean, that's what makes art beautiful, is every time you look at it, you see new things. And same with music. I mean, you're always reinterpreting and re-experiencing and seeing Hamlet. Every time you see Hamlet, there's something you didn't notice before. So there's poetry. One of my former graduate students, herself a very fine artist, Angela Kantrowitz, wanted to apply what Masaki and I had done to artists. She took 9 artists for whom sketching is their bread and butter. That's how they earn a living. They love sketching. She had them sketch. She was sure they could talk about it. They couldn't. And again, she videotaped them and worked with them after the fact. So they described it as a conversation between the eye, the hand, and the page. And it's unmediated. It doesn't go through language. Language gets in the way. It categorizes things too. It doesn't express what you're doing. And they have the flexibility of the hand. The hand is part of their body. It's the way they think. So, and they, again, wordless, very intelligent and skilled. So artists say their ideas emerge from the page. Here are some of the other things they say. Drawing is creating something from nothing. It enters other worlds. You create a world and then you play in it. Drawing gets a life of its own. Drawing turns into other drawings, drives itself. It's exploration, finding things, discovery. It focuses attention, engages, it calms. It's fun, playful, safe. So and I have more quotes, especially from William Kentridge, but no time to go into it. So wordless communication, and we've had examples of that, and we'll have more. Chen Zheng and I looked at videotapes of strangers putting a TV cart together. There are two students, they get a picture of the finished cart and a pile of parts, and their job is to put it together. So they do it almost without words. They use words at the beginning to figure out what the thing should look like, and they don't decide who should do what, and they don't decide how the parts should fit together, just what it should look like at the end. And then they put it together almost without words. Let me show you a couple of videotapes. So he hands her the screwdriver. He knew she needed it. She didn't ask for it. He takes the part, he hands them the part. Again, they don't coordinate in any verbal way. Their coordination is through the objects and through the joint model of what it should look like. Again, there's no leader here. They don't decide who's running the show. They just do it. Here's another one. He knows she needs the screw, and he knows when she'll need it and passes it. Again, they're wordlessly doing it. Okay, where are the words? I mean, basketball, any fast-moving sport is amazing, and there's no time for words. It's not possible anyway. But these players are monitoring their own team and the other team, faking the other team, passing to their team. It happens split second. I can't figure it out. Okay. Now I want to show you some gestures for thinking. Most of the work, and there's considerable work, and we've done some of, is showing how gestures are effective for other people over and above speech. This work we did looking at gestures for ourselves. So people are alone in a room, not talking to anyone, the door is closed. These are students. They're required to learn very difficult material because they're going to be tested, and they know the tests are hard. So some of the material is descriptions of an environment. They locate 8 or 4 landmarks. They're told from 2 different perspectives. This is part of the description, not all of it. So let me show you what one person is doing. Watch her hands. She's not looking at her hands. She's reading. And she's essentially making a map on the table. Some do it in the air. Some do it on their laps. We can't get the camera on them. So they do it in different ways. Most make lines, the paths, and points for the landmarks. And they do it over and over again in parts and then the whole together and in different ways. About 75% of our participants do it. They don't do it on every description. When they do it, they perform better on the test. And for the descriptions that they don't gesture and it's random, they do worse. So what the gestures are doing is creating spatial motor maps of what they're reading. And we know from considerable research that forming spatial mental models helps learning. So when you look at these people, you get the feeling that their hands are translating the words into thought. So here's somebody else, again, doing she does look a minute at her hands, and she's even gonna move. So some of this is in the air, some of it is on the table. But for the most part, they're making this without looking at their hands, reading and translating into their hands. So car brake, we explained it's an explanation for how a car brake works. Here's somebody learning that. He's especially expressive. Where's the arrow? It's not loading. Come on, there. So he makes very big gestures. He's especially, and he'll do it more than once. Those are small ones doing part of it. Again, a big one. And you see the concentration on the words and the embodiment in his body. That's not a gesture. But coding these, we could code the maps into lines and dots. Coding these was hard because all we could code was making a model, and that there was no ambiguity on. We had two coders. I'll show you one more. It's again got a load. She's learning a schedule. So it's like a matrix. Come on, where are you? There. So again, big gestures, some of them use the knuckles of their hands to make a matrix. Some of them draw it on the table in the air. And she does a little bit, look at her hands, where have I put that event? So again, when people do this and they do it spontaneously, we say nothing about it. They do better, they comprehend better. So we've looked a bit at gestures and collaborations, and these were two people that had to find a route to rescue wounded people after a hypothetical earthquake. And they're having a conversation of gestures over the map. They're not looking at each other. The conversation is over the map. Let's see if there. And they take turns and they amend each other's routes. They entrain on each other's routes. When they do this, as opposed to having a shower curtain between them, they perform better on the tasks. Their maps are better. When they have a shower curtain between them, the maps they draw, even though they verbally agreed and are looking at the same map, their maps differ 30% of the time. So having that diagram and being able to gesture over it facilitates the collaboration. They're much happier. Okay, so the hands make models of thought. The models are spatial motor, not visual. They're direct representation using elements in spatial relations. Diagrams in the air or on the table. They enhance comprehension, pardon the typo, and memory. A bit of ancient, let's look at ancient diagrams. This is 45,000 years ago in Sulawesi, recently discovered, amazing. Chauvet, this is Utah. You see this bows and arrows and animals and stampedes, they're everywhere. This used to be the oldest map. I mean, it's after writing. This one is before writing. It's now the oldest map. We keep finding the oldest. So it's some 13,000, 14,000 years ago. It's this big. And it was found in a cave in Spain, and it depicts the environment outside the cave. So South Sea Islanders, bamboo strips are the ocean currents. The shells are islands. They're used for navigating oceans 2,000 miles. And so you can't see from island to island, and at least some of these people got home. Events in time, this was a petroglyph, and the drawing of the petroglyph, it was dated 6,000 years ago. What is it? There are two suns. And it was in Kashmir, and an Indian astronomer dated the drawing to 4,000 years ago and found there was a supernova. Then, so there were two suns in the sky, and it was a dramatic enough event that it got inscribed in stone. So we have explanations like how to do something. We had diagrams like that this morning. Making bread, Egyptian tomb. So we have events in time, we have repeated events, how to do them, how to explain them. We have time per se. These are a little more modern. We have tallies, and tallies again are very ancient all over the world. You find remnants of tallies. So ancient graphics represent things, bows and arrows, people, animals, space, maps, time as events or as things that happen in time, or as abstracted as calendars, and primitive numbers. Modern graphics, and I don't have time to show you our examples there, the same. So these are basic concepts important to human beings. And for the most part, there are special places in the brain that encode them. Time is more complicated, but there are many internal clocks. So these are encoded in our bodies and our brains, these concepts that are so important for us to exist. So now I'm ending, and I want to pull things together in a concept that I call abstraction. It's an ugly word. Latinate words are ugly. What can I say? They sound technical. So it's a contraction of action, space, and abstraction. And the contention here is that actions in space create abstractions. This is the world that nature gives us. I was happy to see this as the Mac default screensaver. Not this exactly. This is my photo, but another one like it, redwoods in California. So this is the world that nature gives us. Also, this Save the Asphalt. This is the world that we design. So we put our minds in the world, in our homes, in our houses and schools and stores are organized by themes. We have rooms that serve different purposes, that bring together different categories of things in the same room. So everything for preparing food, many different categories are in the kitchen, preparing and eating often. Everything for socializing is in the living room, for cleaning and the bathroom and so forth. So themes organize many different categories for the same function. It's our minds in the world. We design our houses that way. We put categories, hierarchies, and orders on our bookshelves, in the grocery stores, on our kitchen shelves. There are categories and hierarchies. In our place settings, we have one-to-one correspondences, repetitions, cycles, embeddings. These are all abstractions. They're there in the world. Think about our children growing up in this world that's all designed, as opposed to the world the hunter-gatherers had. I mean, the designed world is telling us a lot, not necessarily intentionally, but it is communicating a huge amount. We have repetitions, symmetry, embedding one-to-one correspondences. This is Padua, one of my favorite cities. Rows, columns, repetitions, one-to-one correspondences in 3D. It's everywhere. And we use those organizations that we've created by actions in the world. We use them to design graphics that will communicate. So we have timetables, rows and columns and boxes, periodic table, rows and columns and boxes, horizontal rows, probably the most impressive diagram ever. And we have jokes, Morris Steinberg. Comics, I have a whole presentation on comics, but don't have time, just show you one image. And we use those designs to make inferences. Archaeologists make inferences about social hierarchies, economic transactions, and so forth, the way space is laid out. So we don't just design the world. It's hard to find places in the world that haven't been designed. Parts of Greenland, maybe, but parts of Siberia, maybe. But it's most of where people live. We've designed, changed it. We don't just design the world, we live in diagrams. The world has become a diagram. This is airports looked at from above, where the transport cars can go, or trucks, where the planes can go, where the buses can go, where people can go. And in the streets that we navigate, they enable our movement and constrain our movement. So we live in a diagram. Done.